All right, so we take a look at lesson 2.2. The quick review. The standard form of a quadratic function is this. So again, this is the algebraic definition. Before they add any numbers, any A, B's, or C's in here, that's just the generic form. So when I'm talking throughout these lessons and I'm just saying, hey, the formula is B divided by 2, or it's B squared minus 4AC, remember, that's where these A, B's, and C's are coming from. A common problem that people are doing every year is that when I say, what's my B value? They'll say, oh, it's 3x. Or what's my A value? Oh, it's negative 5x squared. But remember, A, B, and C are just numbers, and you could see that here. See how A is in front of x squared? It doesn't include x squared. It's just a number in front of it. B is just the number. They call it the coefficient that's in front of x. It doesn't include x. B is just the number. Where A, B, and C are real numbers, and A is not 0. Basically, because if A was 0, you wouldn't have an x squared term, and then it wouldn't be a parabola. If there was no x squared term, it would just be a linear function, like y equals 5x plus 7. Use the formula h equals, they read it, or you can read this as negative b over 2a. I like to think about it as the opposite of b over 2a. To find the x coordinate of the vertex, in the axis of symmetry, that's what we talked about in lesson 2.1, is that the x coordinate of the vertex, that h value, is going to give you the axis of symmetry. Substitute 0 for x to find the y-intercept of the quadratic function. So for the first example, this function can be used to predict the profits for a company that sells ebook readers for a certain price, x. What is the maximum profit the company can expect to earn? So what I want to kind of write here is when they use these keywords like maximum profit, this is what they're talking about. They gave you that really crazy quadratic, right? And again, I'm not super concerned about it. But notice that that quadratic is negative. That leading coefficient is -8. So I know if I graph this, it would look something like this, right? It would be a negative quadratic, it would be a frowny face, and it would look something like that. Well, when they start using words like find the maximum profit, what they're saying is that after I sell so many ebook readers, so after I sell 1, 2, 3, 4, 5, 100, 300, right? However many, after I sell so many ebook readers, this is the amount of money I'm making, 1,000, 2,000, 3,000, right? So this is money. This is the number of ebook readers. Okay. So what they're saying here is after I sell so many, and I don't know what the numbers are, but after I sell so many, I start making a profit. I keep making a profit. After I sell a certain amount, I'm making the maximum amount of profit. Okay. That's the highest point of my parabola. That's called the maximum amount of profit. Or that could also be called your vertex, right? Your vertex will tell you the maximum amount. But then what you'll notice is that parabola comes back down. So if I take an item, a solid item, like the number of an ebook reader, and I sell, you know, so many of them, I'll make this amount of money. But once I start selling them for more money, I'm not going to sell as many. So I'm actually going to sell less, and I'm going to make less money. And at a point when I sell them for, like, I don't know, something that they're not worth, I'm not going to even sell them. It's just going to be zero profit. So I just wanted to clue you into that little keyword of maximum profit. When they say maximum or minimum, they're talking about the vertex. You automatically know that. The maximum value of a quadratic function occurs at the vertex. So we're going to use that formula. H equals, so remember my vertex is going to be H. I said H and I wrote K. H, comma, K. So H, that's going to give me that maximum number. So they have a formula for that. Anytime you want to calculate H, you can just use negative B over 2A, or the opposite of B over 2A. Here, my A value is -8. My B value is 880, and you're not using C, so I'm not worried about it. So it's going to be the opposite of B, which is -880. Divided by 2 times A, 2 times -8, which is -16. So if I do the math, -880 divided by -16, that's going to give me +55. So what that's telling me is after I sell, what is it? This sells ebook readers for a certain price of X. After I sell ebook readers for $55 a piece, that's going to give me the maximum amount of profit. So let me sketch another little picture here real quick. So we're going to call that 55 bucks a piece. That's going to be where my vertex is at. So hopefully I can sketch this good. So that's my H value right there. So after I sell an ebook reader for 55 bucks a piece, that's going to give me that maximum profit, because that's what my Y value or my Y axis is all about. So to figure out what that is, we just need to plug in 55 for X. So take that parabola, replace your X's with 55 to figure out what Y is going to be. So -8 times 55 squared plus 880 times 55 minus 5,000 will give you that profit, that maximum profit. I think they do the math here for you. So if they sell ebook readers for 55 bucks a piece, that's that sweet spot. They're going to make a maximum profit of $19,200. All right. Find the vertex and the y-intercept of the quadratic function and use them to graph the function. So same thing as 2.1. I'm just going to sketch it super quick, and we'll take a look at it. If you want to see exactly what it looks like, go to Desmos, type that in. You can see exactly what that quadratic looks like. Find the vertex. Actually, we'll start off by finding the y-intercept because that's super easy. The y-intercept is always that C value, okay? So when I go to graph this function, it's going to cross the y-axis at 15. So that's super easy. Y-intercept is 15. The vertex, you got to use that formula. So remember, my vertex is h comma k. And to figure out what h is, I just need to use that formula, negative b over 2a, or the opposite of b over 2a. A is 1, b is -6. So the opposite of -6 is +6. A was 1. Do the math. 6 divided by 2 times 1, that's 3. So my h value is 3. Let's make sure they want us to find, yep, the entire vertex. So we need to plug that into our function. Number 16, y equals x squared minus 6x plus 15. In this case, h is 3. Remember, hk, that's the same thing as x and y. So I'm going to take that parabola, that quadratic, and replace x with 3. And then do the math. So parentheses first. I can't do anything inside the parentheses. Then exponents. So 3 squared is 9. Now multiplication and division from left to right. So -6 times 3 is -18. And now I can add and subtract from left to right. 9 minus 18 is -9, plus 15 is 6. So I know that my vertex is at 3, 6. So there's the two things I need to find, the vertex, and again, the y-intercept. It's always that constant at the end of your problem. So they want a quick sketch. They want us to graph it. Again, I'm not going to put a lot of detail into this. My vertex is at 3, 6, so 3, 6. My y-intercept is at 15. So it's going to be a little off scale, but it's going to look something like this. So that is 15 right there. And that's 3, 6. Kind of a crappy scale, right? But again, if you have a hard time imagining that, if that's just really throwing you off, just go to Desmos, type that in, and you can see exactly what that parabola would look like. Again, the two pieces of information, just make sure you put the vertex at 3, 6, and make sure when you sketch this, the y-intercept, the part that crosses the y-axis, is at y equals 15. 17 looks like it's exactly the same. Y equals 4x squared minus 15x. 15x plus 9. 4x squared minus 15x plus 9. Again, y-intercept, super easy, 9. So you could say something like y-intercept is at 0, 9. You could just say y equals 9. I mean, there's lots of different ways to annotate it. Just make sure you know that it crosses the y-axis at 9. Then my formula for my vertex, opposite of b over 2 times a. 15 divided by 8. I don't think that can be reduced down at all, so it's just going to be 15/8 for my vertex. That's pretty nasty. Let me make sure that that's correct. They're putting it as a decimal in the book, so you could leave it as 15/8. You could put it as a decimal. It's up to you. I like, fractions. I'm going to leave it as 15/8. If you're more comfortable with the decimal, go ahead and type that in your calculator and figure out what that is. So now, if that's my h value, I can just plug that into my function to get my k value. So y equals 4 times 15/8 squared minus 15 times 15/8 plus 9. Do this in your head. Type it into a calculator. Just make sure you're careful when you're typing these things into a calculator. But once you do the math, 15/8 squared, then multiply it by 4. Then you'll do negative 15 times 15/8, and then you'll add and subtract them from left to right. You're going to end up with y equals, I'm going to go ahead and take the easy route. So 15/8 is the same thing as 1.875. So y equals 1.875 squared minus 15 times 1.875 plus 9. Again, type that in a calculator, do it by hand. 1.875 squared, multiply it by 4, negative 15 times 1.875, then add and subtract from left to right. You should get negative 5.063. So kind of some nasty numbers here, but that's okay. So my vertex is going to be at 1.875, comma, negative 5.063. So if I sketch this graph real quick, 1.875, I don't know, something like that. This vertex is positive, so it's going to be a happy face. And it looks like it's going to cross at positive 9. So I did my best. Imagine that crosses at positive 9, and this vertex is at 1.875, comma, negative 5.063. Again, always for the sake of time, I don't want these things to be hours long. I didn't do this step by step. But again, I'm just doing that, following PEMDAS, type that in your calculator, and you could solve that step by step to get negative 5.063. '18, write an equation in standard form for the parabola that passes through the given points. So this is the one where you're basically going to take those 3 equations, such as the generic functions, the generic quadratic functions, and plug in the x and y from each of these given points. So x is 1, y is 5. You'll plug that into one of them. Then x is 3, y is 7. X is 6, y is 25. So it's going to look something like this. Y equals ax squared plus bx plus c. So we're going to plug in x is 1, y is 5. And then we can simplify that. 1 squared is 1, so that's just going to be a. B times 1 is just b. And then plus c. So the second one, I'm going to use that same generic quadratic algebraic definition, and I'll plug in x is 3, y is 7. So y is 7, x is 3. And then go ahead and simplify. And then same thing with the last one. X is 6, Y is 25. So I'm going to squeeze that in over here. X is 6. Y is 25. Simplify. 6 squared is 36. Okay. So what I did is just plugged in the 3 given points, the X and the Y's, into that generic function, and it gave me 3 equations. This is that one that it's going to take up some room, so write small, use your space wisely, and now we're just going to use elimination. I think back in the lesson, if I remember correctly, they used matrices to solve this. We skipped that unit or that lesson. We didn't deal with the matrix unit, partly because we didn't have the calculators for everybody to do it. If we were in class, we would have taken a look at that. But we're going to stick with the old reliable elimination method. With these 3 equations, since C in all 3 of these is just a 1C, I think that's the variable I'm going to eliminate. If you need some reminders on how elimination works, either go to YouTube, go watch one of our past videos when we looked at the elimination method, but I'll walk you through it here if you need a quick reminder. So the first step is pick a variable to eliminate. Basically, if I add or subtract these equations together, I need to eliminate A, B, or C, one of the 3. The problem is if I choose A or B, I'm going to have to multiply one or both of the equations to drop out A, because that's an A, that's a 9A, that's a 36A. C is all 1C. That's 1C, 1C, 1C. So I think what I can do is if I eliminate C, I can just subtract them, and it's just going to eliminate them. So I'm going to take equation 1, and I'm going to go ahead and subtract equation 2. So it's going to be equation 1 minus equation 2. So equation 1 is 5 equals A plus B plus C. Equation 2 is 7 equals 9A plus 3B plus C. And when I subtract these 2 equations, 5 minus 7 is negative 2. A minus 9A is negative 8A. B minus 3B is negative 2B. And then C minus C is 0. So there's my elimination. I eliminated C. Well, the thing with elimination is your first step here, you've got a choice. You can eliminate A, B, or C. It's up to you. But once you eliminate a variable here in step 1, the next step, you have to eliminate the same variable. So after I chose to eliminate C here, there's 2 things that have to happen. I used equations 1 and 2, so I have to use equation 3. I don't have a choice. I have to involve it. But I can choose the other one. I can use 1 or 2. It doesn't matter. I'm just going to use 1. So I'll take equation 3. And I'm going to subtract equation 1. But here's the thing. Because I subtracted C, because I eliminated C from the first step, I have to eliminate C in this next step. I don't have a choice. So as we have it set up, we're good to go. We're going to eliminate C. But if it wasn't, you would have to force this step to eliminate C because you eliminated it in the first step. 25 minus 5 is 20. 36A minus A is 35A. 6B minus B is 5B. And again, C minus C is 0. So I eliminated C in the first step. I eliminated C in the second step. That gave me 2 new equations with 2 variables, okay? So now I've got negative 2 equals negative 8A minus 2B, and I've got 20 equals 35A plus 5B. Now I'm going to basically wash, rinse, and repeat. I'm going to do the same step as I did up here. I'm going to eliminate one of the 2 variables. It doesn't matter which one. You can eliminate A, you can eliminate B. I would always choose the easiest of the 2. In this case, I think we're going to have to multiply both equations by something to make them eliminate. I'm going to choose B. If I want these B's to eliminate, it looks like the least common multiple, the smallest number that they'll both fit into, is a 10, right? I can multiply this top equation by 5 and that bottom equation by 2. And what am I going to have? I'm going to have a negative 10b and a positive 10b. When I add those together, that's 0. So let's go ahead and do that. I'm going to multiply the first equation by 5. So that's negative 10 equals negative 40a minus 10b. The second equation by 2, that's going to be 40 equals 70a plus 10b. And look what happens. If I add these two equations together, negative 10 plus 40 is 30. Negative 40 plus 70 is 30a. Negative 10b plus 10b is 0. So I eliminated c's on these first steps. I eliminated b's on the next step. Now I can solve for a. So I get a equals 1. Now I can kind of work backwards. I'm going to take the fact that a equals 1 and plug it into either one of those two equations. It doesn't matter. I'm going to pick the one with the smallest numbers. Hopefully that's just the easiest. So I'm going to go ahead and pick the first one. So negative 2 equals, a is 1, so negative 8 times 1 minus 2b. And if I simplify that, negative 8 times 1 is negative 8. And now look what I have. I've got an equation with one variable. I can solve for b. So I'll add 8 to both sides, divide both sides by negative 2, and I get b equals negative 3. So now I'm going to take this information, a is 1, b is negative 3, and go back up to any of these three original equations. It's up to you. Again, I choose the easiest, and it looks like number 1's the easiest. So 5 equals a plus b plus c. 5 equals a plus b plus c. 1 plus negative 3 or 1 minus 3, it's the same thing. That's 2. I'm sorry, that's negative 2. And if I want to solve for c, I'll add 2 to both sides, and I get c equals 7. So a really long process, lots of work for this problem. But again, you're using elimination, which we've done before, so it's not that much of a stretch. It just takes a lot of work, right? So now that I found a, b, and c, I can go ahead and plug those into that generic function that we had back at the beginning, the algebraic definition. A is 1, b is negative 3, and c is 7. So my final answer is going to be y equals, a is 1, so I'm just going to leave that as x squared. You don't really write 1x squared. You'll just write x squared minus 3x plus 7. Woo! That was number 18. 19, you're doing the exact same thing. So I think for the sake of time, because we're already at about 25 minutes, I'm not going to do that again. If you weren't able to follow that and you need to work through number 19 and you're struggling with that, access that solutions manual, see if that helps you. If it doesn't, I am happy to join you on Zoom to work through that problem. But again, I just don't want this video to be like 10 hours long. So I'm going to skip number 19. Number 20, a golfer is on a hill that is 60 meters above the hole. The path of the ball can be modeled in the equation right there, where x is the horizontal and y is the vertical distance traveled by the ball in meters. How would you use the function to find the horizontal distance traveled by the ball and its maximum height? Well, hopefully, again, you're keying into those words of maximum height, basically saying that you need to find the vertex, right? So if we find the vertex, they gave us that quadratic. This is number 20. Y equals negative 5x squared plus 40x plus 60. That vertex is going to be h comma k, and to find h, it's the opposite of b over 2a. So a is -5, b is 40. So the opposite of positive 40 is -40. 2 times a, 2 times -5. So if we do the math, 2 times -5 is -10. -40 divided by -10 is 4. So we know that the vertex is going to be at 4 comma something, right? All we have to do is plug that in. So it's going to be y equals -5 parentheses 4 squared plus 40 times 4 plus 60. Again, do that by hand. I would always suggest you do those things by hand. I think, you know, that's the best way to kind of keep your brain fresh and keep you comfortable with like manipulating numbers and multiplying them in your head and things like that. You're more than welcome to grab a calculator if you'd like. 4 squared is 16. 16 times -5, what is that going to be? -80. 40 times 4 is 160. And now if I add from left to right, -80 plus 160 is 80. 80 plus 60 is 140. So the information that that's giving me, remember, this is my vertex. This is h and k. So if I had this ball, right, here's my parabola. This function is negative, so I know it's like a frowny face, right? And imagine a golf ball, right? You hit it from the ground, it goes up and it comes back down. So it's going to be at the highest point. It's going to be at its vertex at 4 comma 140. So after 4, I don't know, let's take a look at it. I'm assuming seconds. Where x is the horizontal and the vertical. Oh, okay, so after 4 meters, I think this is all talking about meters. X is the horizontal, Y is the vertical, traveled in meters. After 4 meters, this thing is 140 meters in the air. That's the highest it reaches, okay? How would you use the function to find the horizontal distance traveled by the ball and its maximum height? So I think this is just the horizontal distance at the maximum height. You would have to figure out when this thing hits 0 again, so basically factor it. That would give you that distance, how far it was away. So if we factor this, number 20, you would definitely figure out what these points are. Not only the point when you started and teed off the ball, where it kind of, I don't know, let's go ahead and do this. Right, you'd find out this point where you started and you kicked the ball off. We already found the vertex. After 4 meters, it's 140 meters in the air, but you'd find this point where it hits ground 0, where it comes back down to the ground. The thing here is factoring it. Sure, you could do that. You could use quadratic formula. You could use anything, right, to factor this and figure out what that is. These are kind of bigger numbers, so it wouldn't be super quick to do. But one thing you could do is just realize that this thing mirrors itself, right, across that line of reflection, that line that goes through H. Remember, this distance that goes through H, this distance from that center to the point where you kick the ball off the ground, right? Or where you putted it off the ground, where you hit it off the ground. I don't know what it's called. I don't play golf. I don't have patience for that. That distance between that midpoint and that ball that you hit is going to be the same distance between that midpoint and the time that it hits the ground. Remember, that mirrors itself. The distance is always the same. So if that distance in this case is 4 units away, right? 4 units away, this other point when it hits the ground is going to be 4 units away. Whoops, I'm screwing that up here. Hold on just a second. Okay, got it. So that unit, or that distance is going to be 4 units away. So how far is this? So this is after 4 meters. It's 140 meters in the air. So after this would be, I'm kind of writing myself into a corner. After 8 meters, it's going to be back on the ground at 0 meters. So let's say we kicked off at 0, 0. You hit the ball. After 4 meters, it's the highest it's going to go at 140 meters in the air. And then because this parabola mirrors itself across that line of reflection, After 4 more meters, it's going to hit the ground back at the elevation of 0. 21, the number of issues sold per month of a new magazine in thousands and its profit in thousands of dollars could be modeled by this function. Determine the maximum profit. Again, anytime you hear maximum, minimum, you should be clued into the vertex. Y equals negative 6x squared plus 36x plus 50. Vertex, we've done this a few times, so you should know where we're going here. Opposite of B over 2 times A. 2 times negative 6 is negative 12. Negative 36 divided by negative 12 is 3. So I know that H comma K is going to be 3 comma something. Plug it in. Y equals negative 6 times 3 squared plus 36 times 3 plus 50. Wow, 3 squared is 9. Negative 6 times 9 is negative 54. 36 times 3 is 108. Negative 54 plus 108 is positive 54. 54 plus 50 is 104. So I think in terms of this context of the problem, 3 comma 104 is basically saying the number of issues sold per month in thousands. So after you've sold, again, the answer, I can put it right there, is 3 comma 104. So if it's in thousands, they're saying after you sold 3,000 magazines, the profit is going to be in thousands. So after I sold 3,000 magazines, I'm going to profit $104,000. So those units are super important. Make sure you're paying attention to those units. So it's talking about in thousands.